All right, guys, Mr. Antonucci here, and in this video, we're going to talk about how to find the derivative of a to the x. Now, the chain rule allows us to establish a formula for differentiating exponential functions for any base. So if we think about a to the x, we could rewrite that as e to the natural log of a to the x. And the reason we did that is because e and natural log cancel, and we also can use the power rule for logs. Now there's no calculus up to this point, but we can rewrite this as x natural log a. Why this is significant is now the x is out of the exponent on the a. So if I take the derivative of this with respect to x, then I can use the rule, it's u prime e to the u. So the u is the x natural log a, so the derivative of that is just natural log a e to the u, which is x natural log a. What we do with this is the x natural log a, we rewrite this x as the exponent again, so natural log a e to the natural log a dx. And since e and natural log are inverses, they're going to cancel one another out, and you get natural log a times a to the x. The derivative of a to the x, the rule is itself times natural log of whatever the base is. So now let's look at a couple of examples here. So in this case, for part A, the value of a for the exponential function is just 2. So f prime is going to be natural log 2. Sometimes I like to put parentheses around that, times 2 to the x. And that's it. You can't multiply the 2's together. For this next one, we don't just have 3 to the x, we have 3 to the negative x, so we have to treat that as a u, and u equals negative x in this case. So the derivative is going to be natural log 3 times 3 to the negative x times the derivative of u because of the chain rule, which is -1. Now, to make this a lot neater, we just put the negative in front. Negative natural log 3 times 3 to the negative x. And that would be our answer there. A couple more examples. We have g of x is 1/2 x squared plus 1. In this case, the u is x squared plus 1. And g prime is going to be natural log of the base, so natural log 1/2, times the original function, times the derivative of the u, 2x. We could simplify this a little bit and rewrite it. Now, in this case, none of the halves will cancel with that 2x, and none of them will multiply together. And this brings up an important point. If I have y equals a to the u, and I want to take the derivative with respect to x, and it's understood that u is a function, then y prime is going to be u prime natural log a times a to the u. And that gives us a general pattern for finding the derivative of a to the u power. So this last one here, u is going to be t squared. So u prime is 2t. So p prime is u prime 2t times natural log of the base, natural log 2, times a to the u, which in this case is 2 to the t squared. All right, guys, that's it for differentiating a to the x. Hope that was helpful to you. Leave me a comment down below if this was helpful to you, and make sure you hit that subscribe button for more videos. Take care.